Hello, Legacy students. So today we're going to look at section 5.7, which is the first part of the part 5.7, which is on scatter plots and trend lines. So you're going to want to have those notes I passed out to you during class today, and also a pen or a pencil for you to write with. So this video is going to focus on how to identify the type of correlation scatter plots show, how to plot scatter plots and trend lines, and also we're going to look briefly at causation versus correlation. So, very first, we need some vocabulary. So, the vocab that I need you guys to know is scatter plot, trend line, correlation, and causation. Alright, so scatter plot. This is a graph that relates two quantities by displaying them as ordered pairs, aka points. So you're going to see a scatter plot is basically going to be a graph. It's going to look something like this. There's going to be a bunch of dots all over it. That is a scatter plot. It has points that are scattered about. Now, a trend line is something that's very useful when using scatter plots. A trend line is a line that is drawn on a scatter plot so that it shows correlation. So basically, a trend line is always going to be drawn in the middle of the points just to kind of show the general shape of my graph. So if I have this graph up here, I would start doing a trend line, something like this. I'm going to go down, be something like that. It cuts straight through the graph. Now, correlation, just catching up to that, if you have correlation, that means that the two values relate to one another. And there's three kinds of correlation that we're going to talk about. Two values relate to one another. On the next slide here, we're going to talk about the three kinds of correlation you can see. And causation. Now, causation is a little different than correlation. A lot of people try to group it together. But causation is when one variable causes a change in the other variable. Can only assume causation, causes, they're really easily named. So these are going to want to make sure you have on your notes. So different kinds of correlation that we can have. One in particular is positive correlation. That's when y increases and x increases at the same time. So if you notice, if I was drawing my trend line here, I would have a line that's a positive slope. So positive correlation, positive slope. Now, a negative correlation, y is going to decrease as x increases. So if you would actually draw on the line here, you're going to see I have a negative slope. That lets me know I have a negative correlation. Now, if you look at a graph and you're like, oh, there is nothing going on here, that is no correlation. That can happen. Sometimes there is actually nothing related. They're not related to one another. And that happens. And that allows us to see that one thing does not affect the other. Now, let's take a first look at this example. We need to make a scatter plot and then describe its correlation. So we have the altitude in an airplane and the airplane outside. So they say make a scatter plot and determine the type of correlation. So it looks like our x value is going to be altitude. So I'm going to put altitude down here. And then it looks like I'm going to have temperature going upwards, like that. label my axes. Now, it looks like my altitude goes up by a pretty constant amount of 500. So I think I want to go up by 500 each time here. How many do I got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, looks like I have to go one after the other. I was hoping I could skip a line here. So 1,500, 2,000, 2,500, 3,000, 3,500, 4,000, 4,500, and 5,000. There we go. So I got my X values labeled. Now my temperature, it looks like the lowest I go is 0.6. So it looks like I'm going to have to make sure my temperature values are pretty low. So I think I'm going to go by 10s. Or actually, it looks like we could actually go by 5s. So let's go by 5s here. 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50, 55, 60, and it looks like I'm nothing above 60, so that works. So at 0, I'm going to be at 59, so it's really close to 60, so I'm going to put a dot there. So basically I'm going to make these into ordered pairs. 559.2, so that's going to be really, really close to where I just was, so even closer to 600, or to 60. 1,000 is 61.3, so I'm going to go just a little bit above 60, put a dot there. Okay. 1,500 is 55.5, so I'm going to go up to 55 and go just a little bit above it, just a hair above. There we go. 2,000 is 41.6. About right there. Okay. 2,500 is 29.8, so I'm going to go up to 30 about. Put a dot right there. 3,000 is 29.9. Right up by 30 again. 3,500 is 18.1. About right there, it looks like. 4,000 is 26.2. So that's just above 25 right there. 4,500 is 12.4. About right there. And 5,000 is 0.6, which is really, really close. So now, if I look at my scatter plot with all these dots, does it look like it goes in some form of a correlation? And it kind of looks like, if I were drawing my trend line, like we were talking about, looks like my trend line is going to do something like that, right? Which is a negative correlation. So you're always going to see a negative correlation when it looks like it's going downwards like that. Let's take a look at another one. Estimating values using this trend line. So they want us to graph this data. So it looks like I'm going to have months going downwards here. And I'm going to have weight going this way. Months, I'm going to go by ones, it looks like. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And then it looks like I'm going to need to go by probably by sixes. So I'm going to go 6, 12, 18, 24, 30, 36, 42, 48, 54, 60. Do I have anything above that? Nope. All right. So first month, I'm at 2.5 pounds, which is just almost 3. 2 is 7.6, so I'm just over 6. 3, I'm at 12.5, so I'm just over 12 there. 4 is 17.1, so about there it looks like. 6 is 24.3, so just above 24 right there. 8 is 37.9. Okay. 10 is 49.2. And then 12 is 54.9. So just right above 54, right there. So now, they say draw in my trend line. So let's actually do our trend line here. So it looks like we have something, the trend line that's going to go something like that, roughly. Alright, so then they say, what's the approximate weight of the 7th-month-old panda? So if we want to look here, we're going to look at 7 months. Go straight up and see where it hits my line right there, which is 30 pounds. So it looks like my 7-month-old panda must be around 30 pounds. Now, it's an approximate amount. It's not a perfect amount, but it is a good estimate to know. Now, causation versus correlation. Now, if you remember, causation says that one thing made change on the other. And I cannot have causation without correlation. So first, let's see if we have a correlation here. The number of loaves of bread baked and the amount of flour used. That should have a positive correlation, right? So it has a positive correlation because if I bake more loaves, I'm going to need more flour. So this is a positive correlation. Now, does that reflect causal relationship? Does the amount of flour I use cause me to bake more loaves of bread? Or, the other way, does baking more loaves of bread cause me to use more flour? Yeah, it does. So I have, yes, it is also causal. And for an explanation, more loaves equals more flour. Simply put. Now let's look at this. The number of mailboxes and the number of firefighters in a city. So if the number of mailboxes increase, let's say my city's growing, and I'm adding mailboxes. I'm probably going to be adding firefighters too, because I'm going to need more firefighters to fight more fires if my city is growing bigger. So I do have correlation here. But now, do the number of mailboxes cause me to get more firefighters? Or does more firefighters cause me to get more mailboxes? It's not really a good cause. You can't really find the direct link. So this one is not a causal relationship. Just because I have more mailboxes does not cause me to get firefighters. The increase in people is going to affect the more firefighters. But there is a correlation. Now, you will see this a lot in news reports. They will say there's a correlation between this and that. Now, that does not mean that they are causing one another. A lot of people say, well, the sales of ice cream correlates with the number of drownings. Just because I'm eating ice cream doesn't mean I'm going to drown. It's because I can eat ice cream and swim during the same time, during summer. So that is a good reason to be aware of correlation and causation. It's very common to hear these two words used almost interchangeably, but they're not actually interchangeable. Now, the amount of time you study for a test and you score you receive. There is a correlation for this. If you study longer, you should get a better score. Now, does the amount of time I study cause me to get a higher score? Yes. So this is a causal relationship. Reason being, more study equals better grade. See you later, Sabres. Have a good night.